Welcome to Pure One, Chapter 9.5, where we look at the graph of sine, cos, and tangent, or cosine and tangent. You have done this in GCSE, but where you'll be looking at the positive degrees in A level, you are going to look into negative degrees as well. So without further ado, let's go. Okay. So with sine x, first of all, we're going to draw a pair of axes. Now I have the middle one in the middle. So we have the y value and the x value. So in here we have that one, and then on the, okay, they should be symmetrical, but you know, human drawing, they're not always symmetrical. And I think, to be honest, in my own standard, I think this is pretty good. Right, so what do we have in here? So that's the y cosine x graph. So y cosine x graph. Okay. So first of all, we have the angles. We start with 0 degree in here, and then 90 degree. Where's the peak? That's 90 degree. And then you have 180 degree. You have 270 degree, which is the minimum point. And then you've got that point, which is 360 degree. Okay. We know sine graph is bound between 1 and -1. So that is the lowest point, that's -1. On the negative degree, so after with 0, go to left, we have negative 90 degree, which give you the -1. And then this point, minus 180 degree. That point, negative 270 degree. And this point is negative 360 degree. Okay. So, yeah, so if you put sine, let's say if you put sine negative 90 in the calculator, that should give you a -1. There's that, because sine 90 is -1. Right, what else do we need to know about sine graph? Well, the symmetry. So where are the symmetry? The symmetries are between each semicircle. So there's symmetry, basically where you see the dotted lines right now, where 90 degree, 270, minus 90, minus 270, these are little symmetry line of each semicircle. So for example, if I have, let's say, a 30 degree in here, that will be equivalent to, so that's 30 degree, that will be equivalent to 30 degree in here, and that will be 150 degree. So in other words, the symmetry tell you to do sine, if you put a calculator sine 30 degree and sine 150 degree, you realize they're the same. Or think of something like this, maybe do something like this one here. Okay, so let's say, I'm going to say this one is 60 degree. Okay, 180 to 60 is 240 degree at that point. That will be the same as 60 degree in here. 360 minus 60, that's 300 degree. So you would try sine 240 degree. That's the same as sine 300 degree. Okay, and yeah. Right, so what about cos? So that's sine graph. Cos graph, okay, cos graph. So let's draw in a pair of axes. Some of these black here, because black graphs matter. So that one here. Okay, so that's y, x. Now for cos graph, now for sine graph, we start from 0, but for cos graph, we start from the highest point. Okay, this one. So that point is 360 degree. Okay, and then, yeah. Okay, and that point is minus 360 degree. So start from 0 degree again, okay, and then go 0, that's 90. When it reaches -1, that's 180 degree. When it reaches 0, 270 degree. When it reaches 1, it's 360 degree again. That's 1, and we know the lowest is -1. To be honest, I think today I'm doing quite good graph. You know, normally my graphs look like tornadoes, but today I think I've done a pretty good job. So we have minus 90 degree, minus 180 degree, and minus 270 degree. Okay. So where's the symmetry line? Where the symmetry lines are, you can see between every semicircle. So you can have a symmetry in here, and then you can have another symmetry in here, yeah, or another symmetry in here. Okay, so how do we find the other values? Symmetry. Well, let's say if we have, let's say in here we have 50 degree. Okay, then we can also 50 degree in here. So what it means is if I have 15 here, this value would be minus 50. So if you try to put in a calculator, very interestingly, if you have cos 50 degree, that will actually equal to cos negative 50 degree because they give you the same value. So putting out cos negative 50 and cos 50, they give you the same thing. Okay. Now, what about in here? Let's say we have 30 degree. That will also have 30 degree in here. So 90 plus 30 is 120. 270 minus 30 is 240 degree. So you will try cos 120 degree. That will give you the same as cos 240 degree. Okay. Don't worry about too much about symmetry. It's more about learning, remembering the sine graph and cos graph. Okay. The symmetry thing we'll learn a bit more in chapter 10. Okay, next chapter. Okay, that's a cross graph. So y equals, I forgot to put down y equal cos x. And the last one, 10x graph. Okay, 10x graph. So we've done black, we've done blue, let's do orange graph. Okay, so again, same with here, same with here. Okay, right, so 10x graph, slightly different. So y equals 10x. Right, so this is what it looks like. Okay, so we start with negatives in here. So imagine there's little symmetry in here. So the left from the 0 degree, the dotted line should have the same distance away from the y-axis. So this two sort of space should roughly be equal because they're symmetry. They're symmetrical. So we'll go like this. I'll use a different color to show you the graph looks like this. So we go near touching the asymptote, but not like this. Right? And then we have another one like this. And then we have an asymptote down in here. And then we have graph like this. Okay. And then on this one, I know 10x graph is always the weird one to draw. So, right. So 0 degree in the middle. What else? This one is a 90 degree. Now, if you try putting a calculator 10, 90 degree, what you realize is a maths error. Okay? Makes sense because this is asymptote, but I will mention a bit more later. This point is 180 degree, and this one is 270 degree, this 360 degree. So this is minus 90 degree, negative 180 degree, negative 270 degree, and negative 360 degree. Now 10x is not bound between 1 and minus 1. Okay, 10x is not bound between 1 and minus 1. So yep, so the asymptotes, this one, asymptotes are, so y, not y, y equal x equal. So x equal to plus and minus 90 degree, plus and minus 270 degree, etc. So there are more asymptotes as we expand the graph left and right. So plus and minus asymptotes are, you can tell because if you try 10, 90, or 10 minus 270, maths error, because there's no value for 10x at these 2 points, at these points. Okay, right, so simple S. All right, so simple S. Next one, sketch a graph of y equals sine x from negative 90 to 70 degree. So yeah, we can definitely do that. So let's draw pair of axes. Now I'm going to do more on the right side because the right side is more angled than left side minus 90. So if we know sine graph always start from origin, right? So that's 180, and that's 270. I also need to go minus 90, so minus 90 is here. So what you need is when you say sketch, you should put a 1 and minus 1. So some special angles, not 90, 180, and that's all. Okay, and that's all. So that's the answer, right? And more. Practice question 2. Okay, maybe your turn. Have a go. Have a go at the question. So see if you can recall the graph, how to draw from minus 270 to 90. Pause the video. Have a go. When you're ready, let's play. Well, here's the answer. Okay, so you got the asymptote. You must draw the asymptote. You cannot not draw the asymptote. You must draw the asymptotes. Okay, right, here's the answer. Can't say much. Next one, question 3. Try to think about this. Sketch a graph for what f of x equals sine x plus 3. Hint, think about transformation in chapter 4 that we've done. Okay, the interval is from 0 to 360 degree. Pause the video, have a go. When you're ready for the answer, you can press play, press play, press play, press play, press play. Here's the answer. So that's the original sine x graph. We move up the graph by 3. Hopefully you remember when you have plus 3 on the outside means you move up by 3. The 0 here, that was the original, move up by 3, become 3. It looks like a roller coaster ride. So that's how you can also use modeling in sine x for modeling roller coaster. Okay, right. Yeah, that's all for 9.5.